Hi guys, this is just a quick clip on something I've been working on. I've basically built a setup here using basically microcontrollers, and this is classed under as embedded systems engineering, or the colloquial term now is Internet of Things. And it's really incredible how the barrier to working with these chips have basically been lowered so much in recent years. When I went to university, let me see, way back in 2002-ish, at that time we basically soldered and put together our own PIC microcontroller programmers, and we even had chips that we had to erase the EEPROMs using UV light, and of course later we moved on to using the PIC chips that electronically erasable and stuff. But the point is, we had to set up our own tool chains. Actually at university we were stuck in the Windows world, but personally I want to move everything onto open source and Linux. So later on I got myself set up on GCC based tool chains. But the point is, everything you want to do with the chip is a case of referring up the data sheet, and you end up building all your libraries by hand. And I don't recall it being a big thing on GitHub, with a lot of these code being shared around. But since Arduino came around, and Arduino has exploded basically, and on GitHub, if you pick up a sensor, there is a library for that sensor. And so you can, and now what I've been using with this setup is something called Platformio. Let me just show you up on the screen here what Platformio is about. So let me just quickly move this up. So what's great about Platformio is that it's pretty much a two-line setup on Mac. And what this does is it sets up, forget the IDE, because I mean, yeah, if you like to use IDEs, you can go for it. But I use everything console based and Linux based. So what this means is that I can use my existing dev. Oh great, the site is down. I'm trying to show this. The dev flow is basically with Vim. So basically you use something called Homebrew on Mac, and there are alternatives on Linux of course. But on Homebrew you just do brew install Platformio, and that will install Platformio on your system. And then all you need is a single file in your program. Let me pull it up here. I'm using the mouse because I'm holding the phone in the other hand, but normally I'm much quicker on this stuff. Yeah, crap. I need my other hand, but trying to. Yeah, memory effect is now simply getting me to, because I don't really think about what I type. There's a lot of memory. What's going on here? I can't bring up nerd tree. Okay, that's weird. Oh, it's just playing. It's been really weird today. Okay, that is really strange. Okay, here we go. So let's just open that in another page. Okay, there we go. Wait a minute, it's playing up. But anyway, so basically this is the platformio.ini, and in here, when you set up the project for the very first time, let me show you what that looks like. So to set up a project for the very first time, I will actually do history grep platform. Oops, wrong spelling. Well done, Mike. So you'll see, oh here we go. So this is the command I used to initialize this, well, a previous project on the Arduino board I have, which is basically Decimilla board. That is this little chapter here, because I use this to troubleshoot some I2C issues I was having, because I did something really stupid. And yeah, so you can change your boards around very easily. That's the great thing about this thing. So here I'm using something called the SparkFun thing, which is basically a breakout board for the fantastic ESP8266. And you just give the thing as the board, and this file sets itself up. I do only add this build flags thing by hand. But with that in there, once it's done and my code's in there, all I have to do is platform run. And what that does is it'll go through. Okay, now my file's pretty much the same, so let's just try and add an extra line or something for the moment, just to simulate what the compilation process looks like. And yeah, it's going to start building everything. Okay, obviously realized I have not done anything serious to it, so but yeah, anyway, this compilation progress is, well, let me just kind of scroll up my buffer. You'll probably, oh, so here we go. This is okay. This is what it looks like. So I had changed some stuff in my code, and whoa, it's a lot of, yeah. So here we go. I hit platform, I run, and it does all the linking and all that stuff. And once it finishes linking, if you hit upload, if you give the upload instruction as well, it'll basically do this bit, which is I'm trying to find it, but basically it'll upload. I'm trying to get there, hang on, bear with me. So, oh, here we go. So when you give this command, platform run -d upload, it'll run through the compilation if your files are changed, and then it'll connect to, I've given the baud rate at 115 200 basically, and it'll connect to your serial port. So I'm using the SparkFun FTDI 3.3 volt breakout board, because the ESP8266 has 3.3 volt terminals, and so you cannot really interface 5V TTL. You'll need to level shift stuff. So I just picked up the 3.3V board, and there you go. So once it's set to program, it starts to write the flash. Given the size of the stuff I'm writing, 115/200 is really needed. At 57K baud is yeah, it's well half as it's twice as slow, and at 9600 it's like what, 8 times slow or something. That is painful. That's absolutely painful. Don't try that. And yeah, it flashes. I've been able to get OTA, which is called flashing over the air, working, but I need to, basically the SparkFun chip, I'll go back to the SparkFun chip. This little fellow, I'm going to use the back end of my, well, I'm not going to touch it, but let's see. This chip over here, oops, I almost touched a metal part. How crazy is that? So that chip over there, that's the EEPROM flash. And the square chip is the actual chip. So the EEPROM, I'm going to desolder it. I've ordered larger chips. I've ordered some 16 megabyte chips. Right now this is a half a megabyte chip. I'm going to solder on the 16 megabyte chip because it just gives me freedom to flash whatever I want. And the whole point of this exercise is to be able to get some data off this humidity and temperature sensor by Honeywell. And since the ESP8266 is really great because it has Wi-Fi and Bluetooth all on board, but I only care about Wi-Fi right now, and I can get the sensor data up into the cloud. And so without further ado, let's get into it. So I'm going to start my serial terminal. I'm just using screen. I also have ZTerm, but I like screen for being quick because I'm a terminal whore, I suppose. So I'm just giving power. Whoops, that, okay, shouldn't have. Yep, I'm giving power. Let's see, all some junk came out. It gives the IP address, it's powered on, the thingy bob, and yeah, it's now reading stuff. It's basically starting to send. Ooh, well, there you go. You have my private key. I shouldn't have moved the camera so far to the right. You have the private key to the thing I'm using on Data SparkFun. I don't really care. This is a test thing. So you can see what it's doing. It's reading the temp, and it's sending it all the temp readings. It's very quick, and it shouldn't be. So I mean, I really should just sample, say, every 2 minutes or every 5 minutes, because what I noticed is humidity and the temp, even though the temp may fluctuate, it's still a pretty slow fluctuation. It doesn't change much, which is surprising. But I did some interesting tests, and I'll come back to that. But oh yeah, what I want to show you something else, just to digress quickly, is the fact that I'm running. Also, you notice I'm running a web server on this little chip, which is like, holy crap. So I'm just going to go up here. I'm just going to go HTTP, and we're just going to go 10.0.0.100, and let's see if it should do some magic. Oh boy, it didn't. That's because I can't type while I'm holding my smartphone. Michael cannot multitask. Yes, okay, fine. So, multitasking failure, apologies, and woohoo! Hello from ESP8266. Yeah, I just didn't put much effort into that, but yeah, I just basically served a web page from a freaking microcontroller, and it took, actually for me to do this part, it just took me less than 5 minutes to get the web page thing working, and that is just incredible. I was like totally over the moon. It's a dream come true, and with OTA, I mean, to be able to flash a microchip, I know it has a bootloader, but the point is to be able to flash the running code over the air. Yeah, that's going to be pretty incredible. I mean, seriously, I'm like, woohoo! And yeah, so now just give you a quick summary of what this does. If I come back here, I'm just pumping data into something called data.sparkfun, which is a service that they've exposed. Did it refresh? I think it's being slow. Yeah, I don't know, it's very slow, data sparkfun. I think they're just running like really cheap servers. They haven't scaled these out much. It is so slow, you won't believe it. Comparatively, if I were to just start a page and do YouTube and move to the right, you'll just see how quickly that loads. And I mean, hello, YouTube. I can even probably get something to play by this, and let's have some random clip play, and you can see that this thing on this side is still loading.
With each other. A lot of what we do in the do-it-yourself PC.
Yeah, see, that's just crazy, right? Okay, so anyways, you saw that it's basically a data logging service. It's a simple app, and oh wow, yeah, I think I tripped it up. Nice, Mike. So I'm not going to refresh this page. This is called Analog IO. I think this is also running by SparkFun. It's actually a Rails app, because I tried to change my password and it gave me the standard Rails error, which is a nice touch, because I'm going to be building my own backend service rather than relying on third-party stuff like this. But basically, this is an interesting point here, because what I did was I took this lamp and I placed the bulb very close to the sensor. So what it did at that point was it heated up the air. And mind you, the black trace is the humidity, relative humidity. It heated up the air so much that the temperature, temp C, it went from about 29 and it peaked at about 33. And just that small change was enough to evaporate that much water content from the air. And it even dropped down to something like 63% compared to 76%. That's less. That's almost dropped like 10%, which is pretty incredible. And yeah, these spikes. Basically, every single time I turn on my lamp, it causes a ripple, and you can see that the temp has been switching. But what's interesting is like this bit is all data from yesterday, June 10th, and I think this is from this point onwards is when I started this morning. I made some tweaks to the code. So this is like from today. But if I were to just expand the data out, you can just see from here, I think, from this point, it's been pretty steady. And this is like a change of what? This is, okay, so that's about half an hour. And for half an hour, it's pretty stable. So, I mean, it really just goes to show that if I want to run this as a low power device, which I will ultimately, I don't need to be polling anything more. I mean, and when I say polling, taking sensor readings and posting those to the cloud, any more than say maybe, I mean, 15 minutes is overkill, 30 minutes seems overkill, but I might just do 15 minutes just so we have the data points. Why not? But I will do some calculations. There's another guy who has he's basically the guy with the Swiss accent. He's really fantastic. I love his channel. He has some great tutorials on how to get the ESP8266 running in low power mode. Kevin Dara has also some excellent videos. So I'm going to use quite a bit of the stuff that they've touched on. The Swiss guy, I can't remember his name, he basically goes into all the maths behind calculating how much runtime you'll have based on the low power options that you go with. And I think at around sampling, I say about every 15 minutes or every 30 minutes. That means the chip is basically sleeping for 30 minutes and it wakes up once every 30 minutes, sends out the pulse to the cloud, and oh, look at that! I got some Tom Yum Thai chili paste on the way. Yay! And well, that's it, guys. I seem to have some food over here, which I should eat. And this is like the schematic I just keep on my desk, and that's because I'm using the thing at the moment. This is my oscilloscope from the time I used to be at uni. I got it about 2008 and it hasn't been used since, and it's 2016. I started up and it works fine. It's insane. And just a quick overview. This is like this is a breakout box that takes power from a hacked up ATX PS. You can see it's all corroded, and I can just move the lamp around. I hope I don't fry my finger. Ah, there we go. You can see it's horridly corroded because we have very bad corrosion here in Sri Lanka, at least where I am, because I'm very close to the sea. And yeah, I've got basically a 5-volt regulator and 12-volt regulator, and I punch holes into the box, and I need to wire up an LED and a switch at some point. At the moment I haven't done that. And then I got crocodile clips, a few other bits, and that fan is just acting as load on the 5-volt line. And yeah, so this is my tiny setup here, and I actually can turn this lamp around maybe, but it's not gonna work. But I was just trying to give a quick look at the rest of the tiny lab. It's really messy. This room is just really not touched much. And then the guys just came and installed an AC here. You can see it's an old broken AC. It's absolutely terrible. So since the workmen were here, my mom just covered up all the stuff over there. But it's basically all the toolkits and boxes and stuff. This is another old project I built where I use an Atmel 80 mega to write stuff to these blue LEDs. Very much. If you actually watch 24, I think go and watch like the start of season 1 or season 2, or maybe season 3. I can't remember, one of those. And Jack Bauer basically has to defuse a bomb, and the LEDs on the bomb basically look exactly like that. So I want to build a bomb countdown timer, and it was a whole lot of fun. So I now have my own bomb countdown timer. So if you live in Syria or in that region, do not contact me. I will not sell you my bomb countdown timer. Okay, Mike, you shouldn't be saying this kind of stuff on YouTube. Yeah. So that's it, guys. Give me a thumbs, like up, subscribe. I'm really gonna getting back into my electronic stuff, and I hope to post quite a bit online. Oh, and before I finish, oh boy, almost forgot. I'm open sourcing my libraries for Arduino, and I'm aiming to. So what I'm trying to do with these libraries that I'm sharing is I find that the quality of the code is not so good. A lot of Arduino hackers do not have a solid background in programming in C. And I'm doing my best to maintain the code quality along. I mean, because when it comes to embedded stuff, people only really care about functionality. They don't really care how neat the code is, whether you're doing things in the correct manner, you know. So I'm trying to keep my code more C-centric than Arduino hacker-centric, you know. So it'll be more C-ish. Of course, I'm using things like byte rather than Uint8, but that's just a minor niggle. But the point, this library is pretty tiny, and it's got a small footprint. This is just the HI6130, and it's easy to use. I mean, you can see this has got like single method called read at the moment. So you just hook it up. You just say sensor dot. You can call this whatever you call it, and then I've called mine sensor. And in the main app, you just say sensor dot read. And it does everything for you under the covers. You don't have to mess with anything else. It's brilliant. So I'm basically extracting all these out of my bigger project right now. So I'll be extracting the web server out and all the other bits, and see what can be reused in other projects and stuff. So there you go. It's IoT Arduino libraries under my name, BSOD Mike. Give me a thumbs up, like, subscribe, and tell me what you think. Thanks again. See you until next time. Bye bye.